All right, guys, we're gonna get new notes today. And I think we'll be spending 2 days on this project, so we're not doing it all today. Great. So, just a reminder, you guys, that, next week, Thursday is the last day of the trimester, and for you guys, it'll be the last day of math for this class for the year. Make sure that, so next Thursday, when I leave here at 3:30, unless if you were sick next week, that would change things, because obviously, say you were sick Wednesday and Thursday next week. Then you'd come and see me that following week and I'd give you time to get stuff made up. But if you're here next week, everything's due on Thursday, okay? And just so you're aware of that. And as far as if you have tests or quizzes to make up, basically Monday, Tuesday, Wednesday, Thursdays after school work good for me. And then Mondays and Fridays in the mornings usually work. So, but Monday through Thursday after school works. So, all right, so today or yesterday and the previous day, we were multiplying and simplifying expressions and dividing them. Today, what we're gonna do is add and subtract them. And from what you see today, it wouldn't be as bad, but adding and subtracting, these are harder than multiplying and dividing. I did try when I made the notes for this to make the problems that weren't as tough. But it is tougher to do this. So anyway, what's gonna happen today, if you guys remember back to like whatever grade you learned to add and subtract fractions, if you had like 2/3 plus you plus 4/5, let's say, to either add or subtract fractions, you have to get them over the same denominator. Okay, and so what you have to do is think of, what do 3 and 5 both go into? 3 and 5 both go into what? 15. So I want to get both of these over 15. And to do that, I have to multiply 3 by to get 15. I'd have to multiply it by 5. And if I multiply the bottom by 5, I also have to multiply the top by 5. Over here, I think, what do I have to multiply 5 by to get 15? And that's 3. And then because I multiplied this by 3, I have to multiply that by 3. So now they're both going to be over 15. On the top here, 5 times 2 is 10. And on the top here, 4 times 3 is 12. Once you have them over the same denominator, you can add or subtract them. The denominator just stays the same, so you don't change that at all. And then the top, you add or subtract. Get you the notes, okay? Okay. So on top, we'd have 10 plus 12, which is 22. And then when we did this too, we looked at, could you reduce what is left? And that is another thing that's a little bit challenging with adding and subtracting them, is that you can get them into a single fraction, but then what happens is you may have to factor it again and see if you can simplify anything. And I'll talk about that as we get to that. So here's the first type of problem that we're going to have today, is it's going to give you like 3 denominators. And we have to decide what is the least common multiple of each of those, okay? What I do first is I start with my numbers, and I want to think of, what do 12, 18, and 6 all go into? And that's something that's hard to do just in your head. So how I do this is I take my biggest number and I first write that down once. And I think, do 12 and 6 also go into 18? And 12 does not. Like if you went 18 divided by 12 on a calculator, it's not a whole number. So 18 is not the least common multiple. Then I would multiply this by 2. And I would think, does 12 go into 16? And it does, right? Doesn't it go in there 3 times? 18 goes into 18. And 6 goes into 36, or 18 goes into 36, and 6 goes into 36. If you're ever not sure, just divide it. Go 36 divided by 12, and it has to be a whole number. If it's a whole number, then it does go in there. 18 into here, if you divide it, is 2, 6 into here is 6. They're all whole numbers. That means this, for the number, is the least common multiple. Then when you write the variables, what you do is you have to take the highest power of each variable listed. So if you notice here, I just have a C. Here I have C squared. Here I don't have a C at all. So I'm going to take the highest one, which is my C squared. When I go to my D's, I take the highest one also. I have D cubed, I have D squared, and I have D to the 4th. So I take D to the 4th, and that then would be my answer. Okay. When I go down here, I'm going to do that the same way. I'm going to choose my biggest number, and I'm going to try to find a multiple of that all 3 numbers divide into. If I look at 15, 6 does not go into 15, and 9 does not go into 15 evenly. So that's not that. 15 times 2 is 30. Now 6 does divide into 30, but 9 doesn't. Okay, so that one doesn't work. Then if I take 15 times 3, that's 45. And 6 does not go into 45 evenly. So it can't be 45. Then if I multiply 15 times 4, that's 60. 6 goes into 60 10 times. 15 goes into 60 4 times. But 9 does not divide evenly into 60. So that means we have to keep going. So then I would take 15 times 5, which is 75. And when you try 6 into 75, that doesn't work. It's going to be a decimal. So this one doesn't work. Then if I take 15 times 6, or just keep adding 15, however you want to do that, my next one's 90. So if I took 90 divided by 6, that works. I think it's 15. If you take 90 divided by 15, that should give you 6. That's a whole number. And 90 divided by 9 is 10. So that works. That's a whole number. So as far as what my number is going to be, it's going to be 90. And then we take the highest power of each variable. So here I have an x squared, and an x, and an x. So the highest is x squared. For y, I have a y, no y, and y to the 4th. So it's y to the 4th. Then when I look down here, Don't be surprised if on these, sometimes you have to try several multiples until you get one that works. This is one like that. So if I start with 8, 3 does not go into 8. 8 times 2 is 16. 3 does not go into 16. 8 times 3 is 24. 3 does go in there. 8 goes in there, but 5 does not. So then you would try 32, which is the next multiple, and 3 does not go into 32. And one kind of quick way you can think of this, if 5 is one of your numbers, this number has to either end in 5 or end in 0 for 5 to go into it. Okay, so 5 is not going to go into many of these. So now if I multiply by 8 times 5, that's 40. 3 does not go into 40. 5 does, but 3 does. Then if I either add 8 again or go 8 times 6, it's 48. 3 goes into 48. 8 goes in there, but 5 does not. If I add another 8, it's 56. 3 does not go in there and 5 does not. Add another 8 and it would be 64. And remember for 5, this has to either end in 0 or 5. So that one's not going to work. Another 8 is 72. For 5 to go in here, it has to end in 0 or 5, which it doesn't. Then I have 80. The problem with 80 is 3 doesn't divide evenly into 80. So then we have to keep going. And the next one's 88. That doesn't end in a 0 or a 5. The next one is 96. Doesn't end in a 0 or a 5. The next one is 104. Doesn't end in a 0 or 5. Then it's 112. Doesn't end in a 0 or 5. And 120. So if this one does end in a 0, so it should be divisible by 5. It's going to be divisible by 8. And 3 does go into 120. So like I said, sometimes you have to try quite a few before you find which one works. So our number is 120. My highest power of A is 3. My highest power of B is 3. And my highest power of C is 4. So that would be my answer. Then what we're going to do, if we look at this page, it's the same thing where you're trying to find the least common multiple. But in these, what you have to do before you can do that is you have to factor each of these. Okay. So what I'd have to do is look at this and think, how can I factor that? Okay. So this is trinomial factoring. So I'm going to do this. Okay. Remember, if you do that shortcut, what you can do is look at this and it has a plus and then a minus. So that tells us one is plus and one is minus. Okay, that's x squared. This is x and x. And I don't have that table drawn here, but basically what we need is two numbers that multiply to give us a -8 and add to give us 2. Can you think what that would be? 4 and -2. Very good. Okay, so the 4 is going to go with the plus, the 2 is going to go with the minus, and then that's factored. Now, this next part here, do you guys recognize this as difference of squares? It's got a minus. This is squared, and 16 is a perfect square. And on that trinomial, or I'm sorry, the factoring sheet you guys have, the perfect squares are on the back of that. So with perfects or difference of squares, you put 2 parentheses. One is plus, one is minus. If this is x squared, we do x and x. And if that's 16, you take the square root of that and put it here and here. Okay. Now, when you do the least common multiple, when you factor, every factor that is here has to be listed down here. Okay. So when you're starting out, automatically this whole first part is going to be there. So my least common multiple is going to be x plus 4 times x minus 2. Okay. Another thing, I don't think I really made any like this, but say these were the same, but there was 2 of them, you'd have to write them both down. Okay, so whatever this is automatically going to come down here. When you look at your next one, if there's one of your factors is already listed, you don't write it again. Okay, so this one's already there, so I don't write it. But notice this one is not there, so I do have to write that one. So every factor needs to be included. Okay, so this is our answer. All right, now if we go here and we look at how do I factor this? Here I have a trinomial and a trinomial, so I'm going to do trinomial factoring twice. Okay, so this is plus minus, which is right here, and notice it has a plus and a minus. It's x squared, so we have x and x. And then if you like to do that little chart, it would be 2 factors of a negative 12. And if there's nothing in front of that x, you want it to add up to 1. So can you guys think of 2 factors of negative 12 that add to 1? Or negative 3. Thank you. So the 4 goes here. The negative 3 would go by the minus. Okay, so I have that factored. Now I'm going to factor x squared plus 6x plus 8. Okay, and this one has plus plus, which is rule 1, which tells us both signs are plus. Then if this is x squared, it's x and x. Now for this one, we want 2 factors of 8 that give us 6. 4 and 2, yes. Here they're both plus, so you can put one of them here and one of them there, and it wouldn't matter which one you did in which spot. All right, when I do the least common multiple, okay, I write everything from the first one down. So x plus 4 and x minus 3 automatically come down. When I look at this one, would I copy this one down? No, because it's already there. But this one, would I? Yes. And that is your answer. Now this one, if you notice here, we have just 2 terms. And with 2 terms, there's 2 things you have to look for. One is, could you take anything out front? And could you? Is there a number that goes into 2 and 12? Yes, right? So I can take that 2 out front, and then I would think 2 times what gives me 2x? That's x, minus 2 times what gives me 12, and that's 6. Everybody okay there? All right, now I look at, can I factor this more? Is this difference of squares? This would have to be squared, and it's not. And this would have to be a perfect square, and it's not. So that's factored as much as we can. Okay, so now what I'm going to do is come over to this one and factor this. That's factored as much as we can. Okay, and this is trinomial factoring again. I have minus minus, which is step 4, where one's plus and one's minus. And then if it's x squared, I do x and x. And then certainly if you guys still like the chart and the box, just make it and use it. Don't worry if that still helps you. That's absolutely good. All right, can you think of 2 numbers multiplied that give us a negative 12 that add to negative 4? Yes. Right, so the 2 goes by the plus, the 6 goes by the minus. because these two are negative, that's where you look at these rules. And one's plus and one's minus, okay? The one thing I do have to check, the last factoring sheet I gave you, I'm not sure if I put this on there because we didn't really use it before. And if I didn't, we can either just write it on your sheet or I can reprint it with that on there. So remind me if that's not on there, okay? Now what we're gonna do is we're gonna take everything down that we have to, okay? Now, this one's different as it has that number in front, but if you have a number in front, you do have to bring that down. So we have our least common multiple is the 2, the x minus 6. Okay, so the whole thing comes down. Now here I have an x plus 2, and I bring that down. Okay, there's nothing there. Do you think I'd bring that one down? No. So this is your answer. All right, so that is just one part of this, is finding that least common multiple. And then once you find that least common multiple, then you have to add them together, okay? So I'm gonna just get started on showing you what this looks like. And we'll either do, we have 6 pages. We'll either stop after page 3 or 4, depending. Okay, depending on how much you want to do tomorrow. Okay, so this one, notice the bottom has a 2 and a 5. Can you guys think just off the top of your head, what do 2 and 5 both go into? 10. So your least common multiple is going to be 10. And then do you remember how you take the highest of your powers of your variable? So it'd just be x, okay? So when you do that least common multiple, you do it of what's in the denominator, okay? Once you figure out what that least common multiple is, then we have to add the fractions. And to do that, what we're gonna do is we're gonna put each of them over our least common multiple. Okay, so I have to think, what would I multiply 2x by to get 10x? 5, right? So I'd have to multiply the bottom by 5 as well as the top by 5. So now on the bottom here, I do get 10x. And on the top, I'd get 5 times 3y, which is 15y. Okay, now let's go to this. I have 5x, but I need 10x. So I think 5x times what would give me 10x? 2, right? So I need to multiply this by 2 as well as that by 2. Now that would give me 10x on the bottom, and 2z times 2 is 4z. Now all you have left, they're over the same denominator, so you can add them together. So they're gonna both be over 10x. And then this, I would just add together. I would do 15y plus 4z and put that together. You can't add them together. And what you have to do is just look at what's left and see, could I factor that top at all? Like, could I take a number out front? And there's nothing that goes into 15 and 4, so you can't factor that. So that's the answer, okay? And we'll do a couple as we go through that you can factor it and then show you what to do with that. Now this next one is minus or subtraction. And one thing that I do whenever I have subtraction, I find that kids struggle with subtraction. So what I have you guys do is change this minus to a plus and put the 7 as negative. And I do that every time I see a subtraction, okay? Now we need to decide what number do both 6 and 8 go into. You guys think of that? 24. You could have listed 8, 16, 24, but 6 and 8 both go into 24. Then the highest power of A is A. The highest power of B is B. Okay. So now what I'm gonna do is put both of these over 24AB. And I have to decide, what do I have to multiply 6AB by to get 24AB? What would I have to multiply that by? To just be 4, right? So then I have to multiply the top by 4. And 4 times 5 is 20. So if you're wondering, like, how did we get 4? 4 times 6 is 24, and then you have the ABs, so we didn't need any variables there. Okay. Now I'm going to come over to this one. I currently have 8A, but I need 24AB. So how do I get to 24? 8 times what gives me 24? 3. Now, do you see how I already have an A, but I don't have a B? That means I need to multiply by 3B. And because I did that there, I'm going to do that here. Okay. Now, I already did the top here. Here, I'm going to take -7 times 3B. -7 times 3 is -21. And then I would have the B. Okay. Now they're both over the same denominator, so I can put them together. Over 24AB. And then I'd get 20. And I could write this one of two ways. I could go plus, and usually if you're adding a negative, you put the negative in parentheses like that. And that's completely acceptable to leave it like that. Or you could write it as 20 minus 21B. But plus a negative is the same as subtraction. So you could have written that either way, whatever you feel more comfortable with. So those are two ways to write that. Should we do one more page today? Should we leave the 3 pages for tomorrow? What do you guys think?
Yes.
Leave the 3 pages for tomorrow? Okay. So I'm going to give you a worksheet, which we only know how to do part of right now. And then we'll finish it up tomorrow. Okay, the one that you guys know how to do. Yes, 1 through 8. And then we'll do the rest tomorrow. Sound good? Girl. Your mom first.
Oh, great. Yeah, we lucky that. How did that like happen? I don't know. Normally, I think man, like, normally, like, normally don't know. And we're always straight.